Hi, this next video is going to be on graphing another type of function or equation that you'll often see, and it is called a quadratic function. So, which is kind of an awkward word. So let's just talk about what exactly it is. A quadratic function is this, a function whose terms highest power, so of all the terms, the highest power is 2. It's not at least 2, it is 2. So if you've got like an equation like this, a and b are coefficients, c is some constant, a is not equal to 0. Because if a equals 0, then this would just be a linear function or a constant function. But in this case, a is not equal to 0, clearly. Here's some examples. Y is equal to x to the second power. Maybe, that's a quadratic. Y is equal to 1/2 times x to the second power. Again, look, that second power, that 2, means that this is a quadratic function. Cool. Y is equal to 4x squared minus 6x plus 19. These are all examples of quadratics. For my class, we are going to focus on graphing these 3 types, variations of them. When you get into Algebra 1 next quarter or next year, you will be dealing with ones that get a little more complicated. So for my purposes of my class, we're going to focus on the basics types. So here we go. We have 2 examples to go through today. For this video. Maybe it's nighttime. Who knows? The first example I'm going to give you is, I would like you to graph y equals 1/2 times x squared. So my rules are still pretty similar. I want you to use 0. Okay. So let's plug in 0. We have 1/2 times 0 squared is equal to what? Well, 1/2 times 0 is 0, right? And then 0 squared is 0. Yes, that's not correct. So again, order of operations are huge. We have to take the exponent, then multiply. So again, 1/2 times 0, because 0 squared is 0, and that's going to equal 0. So 1 point is 0, 0. Cool. I'd like to use a positive and a negative, so why don't we just plug in a positive? Let's plug in, well, let's think smart. Oh, this goes back to my linear functions. I want to choose numbers that are going to give me a good graph, that are easy to graph. That 1/2 should be a big warning sign that you're going to have to divide by 2 eventually. Well, if I'm going to divide by 2, I'm going to use the number 2. So we're going to have 1/2 times 2 squared is equal to what? So again, well, hey, I could have multiplied first in the first one, so why not do it again? 2 times 1/2 is 1, and 1 squared is 1, which will give you the wrong answer. So don't multiply first. You always take the exponent first. 1/2, I want to know what half of 4 is. Well, half of 4 is 2. It's not 1. So this point is 2, 2. Let's plug in a negative. I don't want to go too crazy. Why don't we just use negative 2? Awesome. Well, 1/2 times negative 2 squared, again, I'm going to take the exponent first. Negative 2 times negative 2 is positive 4, which is exactly what I had up here. So I get 2 back. So now I have 2 different x values going to the same output. So right off the bat, you might notice, oh man, I'm going to start seeing some crazy graphs. Absolutely, but they're not too crazy. So that point's negative 2, 2. So let's take a look at this thing. All right, let's plot my points. I have 0, 0. I also have a color pencil to make my graph look good. That is 0, 0. Awesome. I have 2, 2. And I have negative 2, positive 2. So if I connect a dot, I end up with a massive V. So my answer should look like a V. Cool. I'm going to make sure that that looks right with my fancy program GeoGebra. So let's drag this puppy on down, move this on over. So by the way, if you noticed on my graph I made, I didn't put any negatives down here. Look at what I ended up on my table with. Seriously. Why would I? All my y's are positive. Anything I put in here is going to get squared. Well, anything squared turns into a positive. Positive times a positive is a positive. My y's are going to be all positive, so I don't need to put the negative part of the graph on here. Why would I waste my time? So this is called being smart with my graph. Why waste paper? Why waste the graph? So I'm doing that on here also. Well, let's check this out. If I put y equals 1/2 x, this looks like a v. That's not right. I didn't put the power on there. Okay, that looks like a v. That doesn't look like a v. That looks like a u. That looks like a cup. It doesn't look like this, right? Looks like this. Ooh. So quadratics and everything else that is not linear, we're not going to use just 3 points. I showed this in class, and I'm going to voice it even more. The more points, the better your graph is going to look. So I'm going to do 2 more points. So I'm going to plug in, let's say, 4. I can divide 4 by 2. Half of 4 squared. Well, half of that is half of 16, and half of 16 is 8. I'm going to plug in -4. And if you're noticing, I'm getting a really neat symmetric look. Because of course you're like, well, you're just going to get +8. So these points kind of mirror each other. And they do mirror each other. That's what's so cool about quadratics is you start seeing these patterns. It's called an even function whenever you get the calculus. You'll love me for mentioning that. It's called an even function. 4, 8. 8 is up here. 4, 8. 8 is up here. Like if I had done my v and just made a v, that doesn't go anywhere near that point. If I made my v, that doesn't go anywhere near that point. So the more points that you plot, the better your graph is going to look. And that's what I want. I want a good looking graph. Now, I'm going to show you why I use the computer program to show the other graph. Because man, when I do this by hand, I am not that good at it. So I apologize for the viewers at home. I draw like little mini lines over and over again. I'm like, wee, and then I gotta like do this little sideways thing, and then because it kind of goes flat. Oh man, that looks decent. That looks good. And by the way, this might take you a few times. Take your time. Do not feel rushed. Redo this part and make your graph look good. So it kind of looks like a cup. Mother of all equations, right? If there's a positive in the front, that's the mother of all linear equations. If it's a positive in front of x like this one, that's +1/2. This is the mother of all quadratics. Mother of all quadratics. So if there's a negative in front, well, what's the opposite of this? Brr. Like an umbrella. So there you go. That is the graph of, oh, I forgot to label my axes. This is the graph where y equals half of x squared. That's the graph of that. Cool. One more example. Let's do it for negative x squared. I'm going to kind of go a little fast, but at first I'm going to say this. I have a negative, and I'm plugging in 0 squared. There's a negative out inside. In fact, every single one of these is going to start exactly the same way. Do not forget about this negative, because I've seen so many people get these questions wrong. That negative that's in the front is so important. In fact, we are actually graphing the father of quadratics. This is Dad. This is the father of all quadratics. I would put a 1 right here, because really, you're going to multiply by -1. There's no number right there, it's -1. So you're going to end up multiplying by -1. -1 times 0 squared is, 0. So this is just 0. -1 squared, well, it's going to be -1 times +1. but a negative times a positive is negative 1. 1 squared is 1, so negative 1 times 1 is what we get, and that's negative 1 again. This negative makes everything that comes out negative. 2 squared is negative 1 times 4, negative 4. Negative 1 times negative 2, negative 1 times positive 4, negative 4. Wow, all of these things are negative. So when I make my graph, and by the way, I want my ordered pairs. Oh, positive 1. When I make my ordered pairs, I'm noticing all my y's are negative. All of them are negative, except 0. 0, of course, is not negative. So when I graph this, here we go. Let's get a fun color out. Yay, fun color. Here we go, 0, 0. And again, notice I'm choosing 5 points. At this point, I would choose points that are going to give me a nice curve. If you're only getting this part of the curve, you need to choose more points because you got to see the dip. You got to see that dip, or the valley, the hill, one or the other. Negative 1, negative 1, positive 1, negative 1, negative 2, negative 4, positive 2, negative 4. I also know that negative 3 is going to give me negative 9. Positive 3 will give me that one. Negative 4 will give me, let's see, 2, 4, 16. Mr. V, why are you adding more points than you actually did on the table? Because, guys, the more points you have, the better. And I know my graph sucks. So if you ever think you need to do more points on a table, do it. Make your graph look good. You don't want to graph garbage. Graph something nice. All right, here we go. And I am putting lines on the end because they keep going on forever. Can't stress that one enough either. So that's that. That's graphing quadratics. This is the father of quadratics. Your arm should be kind of leveled out. And then this is the mother of quadratics. Mother. So that's quadratics. Order of operations, exponent, then multiply. Exponent, then multiply. Always. Remember your order of operations. Have a great night. Download the GeoGebra program if you have a computer. I highly recommend you play with this a little bit. It's a free program, GeoGebra. Great program. It is free online.